Dynamics of capillary exchange. So here we're going to be focusing on how the fluctuations of pressures are going to be focusing on the dynamics of how gas enters and exits the peripheral or pulmonary circuit, right? So this law begins off talking about Starling's law. So Starling's law states that the capillary filtration pressure is correlated with the change of filtration minus absorption. So filtration is nutrients going from the blood to the interstitial space, whereas absorption is going from the interstitial space back into the bloodstream, right? Before we get started with actually showing that capillaries change, we're going to be looking at two different types of pressures that are important. So the first type of pressure is called hydrostatic pressure. So hydrostatic pressure is the pressure that is generated that pushes everything out of the system of interest. So if we have the capillaries, it's pushing out of the capillaries. If we have the interstitial space, it's pushing out of the interstitial space. And this is abbreviated as P, whereas we have osmotic pressure. Osmotic pressure is into the system. And this is abbreviated as pi. We have two systems that we're going to be focusing on, the capillaries and the interstitial space, and we have two types of pressure. So how many types of pressure are going to be relevant? Well, we have 4 total, right? So for the sake of demonstration, I am going to just draw a interstitial space here with bound to the capillary next to it. And the reason for this, I'm saying this in the beginning, is because this is a dynamic function, and it does not necessarily mean that the interstitial space is on top of the capillaries, right, in terms of direction. This is on the bottom, it comes out of the board, goes into the board. It's a 3-dimensional parameter. But here, what I want to do is I want to show direction of where each pressure is going, okay? So you have, number 1 type of pressure. This is the hydrostatic pressure of the capillaries. So hydrostatic pressure of the capillaries, so the system of choice is the capillaries, and it's saying going out. So having labeled here the capillaries and the interstitial space here, we can say that number 1 goes into the interstitial space. The hydrostatic pressure goes into the interstitial space, right? And so for number 2, we have next is the osmotic pressure of the capillary. So osmotic pressure of the capillary says that it goes into the system of choice. The system is the capillaries and going into the system. So here, as number 2, we can say it's going into the system. All right. Number 3, we have the hydrostatic pressure of the interstitial space, right? System of choice is the interstitial space, right? And it's going out of the system. So it's going downwards towards back into the capillaries, right? And then finally, the last color here, we're going to look at the last type of pressure is the osmotic pressure of the interstitial space. This is the system of choice is the interstitial space and going into the system here. And then we can label that 4, all right? And so this is the very general simplified gist of the capillary exchange and where everything goes. And so now we want to figure out what is the actual capillary filtration pressure, right? So here we're looking at filtration. So filtration is indicated as going out of the blood. So which numbers would you think would be involved with going out of the blood? So out of the capillaries. So if you guessed the capillary hydrostatic pressure and the osmotic interstitial pressure, you are correct. So 1 plus 4, and then you're going to subtract it by the reabsorption, which is going to be what? It's going to be the osmotic pressure of the capillaries, which is going to be abbreviated as 2. Let's do 2 plus 3. And this sum gives you capillary filtration pressure, right? And it's important. When we look at specifically the arteries versus the veins. Arteries have a positive they have a positive capillary filtration pressure, whereas veins do not. So why is that? Why do you think that is? Well, from before, we understand that in terms of capillary pressure, capillary hydrostatic pressure, arteries have a very high capillary hydrostatic pressure, right? So their number one is very high, whereas the veins have a very low capillary hydrostatic pressure, right? And so when we look at the actual numbers, arteries here, arteries have actually a positive capillary filtration pressure, whereas veins have a negative. So that could tell you that majority of filtration, because we have a positive capillary filtration pressure, that there is more filtration taking place in the arteries than the veins. However, vice versa, there is more reabsorption taking place in the veins than the arteries.